this session, inheritance, is part of the object-oriented programming. So when we talk about object-oriented programming, or OOP, some of the terms that you have to pay attention to is objects, inheritance, and polymorphism, which we will see in few seconds. Again, we'll just go over the concept. This is a short chapter, just maybe 10 slides or so. We'll talk about introduction to inheritance and what's called polymorphism. So in the real world, many objects are a specialized version of more general objects. Example is grasshoppers, and bees are specialized types of insect. In addition to the general insect characteristics, they have unique characteristics. Grasshoppers can jump, bees can sting, make honey, and build hives. For example, we discussed in class, if we created a class called animal, right? So a dog would be able to inherit a class called an animal. But then again, you have special cases in the case of what? Like a giraffe or a camel. You will inherit what animal class have, but then again, you would add what? A hump, because a camel has a hump, right? Or in the case of an elephant, you will inherit everything that the animal have, but then again, when it comes to the ears, you will create these huge ears and so forth, right? So these are the specialized versions. So you inherit everything, the default, then again, but you will have to create the special cases. So here, bumblebees and grasshoppers are specialized versions of an insect, right? So you have what's called is a relationship exists when one object is specialized version of another object. So a camel will be, let's see, is a relationship, right? It's a specialized version of an animal. Specialized objects has all the characteristics of the general object plus unique characteristics. So the hum will be what? The unique characteristic, right? So for example, Corvette will be, has everything that automobile have. The only difference would be what? Unique characteristic would be the doors will be opening what? Up, right? Is that the only one now? They probably created other cars doing that, right? Okay. An example would be a rectangle is a shape, daisy is a flower, right? Did I go forward too much? Inheritance is used to create an is a relationship between classes. So you have a superclass, which is the base class, and then the general or the general class, and then you have the subclass, which is the derived class. So this would be a specialized class. Okay. So an extended version of the superclass inherits attributes and methods of the superclass, and new attributes and methods can be added. So when we say inherits attributes and methods, we mean that it inherits the state. Remember, we discussed about the state, which is the hands, the legs, and the eyes, and so forth. And then the methods, what you do with those hands and legs, and so forth, right? For the superclass. And then it has new attribute and methods, meaning that a new attribute would be what? A new state, which would be the hump, right? And then method, what do you do with that hump? You know, what does it have, right? It produces oil or fat, whatever you want to say. Okay. So for example, need to create a classes for cars, pickup trucks, and SUVs. All automobiles have a make, year, model, mileage, and price. This can be the attributes of the base class. In addition, a car has what? A number of doors, right? Pickup truck has a drive type. SUVs have passenger capacity, and so forth. In a class definition for a subclass, so to indicate inheritance, the superclass, sometimes called the parent class name, is placed in parentheses after a subclass name. So an example would be a class car and then the automobile. So the initialized method of a subclass, which is the child, calls the initializer method of the superclass, which is the parent, and then initializes the unique data attributes, meaning what the new class would have or the child class would have. Then you add method definition for unique methods. Then we have what's called a UML diagram. Basically, this is a chart that just have 3 boxes or 3 rows on top of one another, right? So here you have it. So that would be the name of the class. What you list here would be the attributes. And then here, what you list in this third box would be the methods, the functions, or the behavior. Or call this the class. This would be the state. This would be the behavior. All right. Then again, this is the parent. These are the children. Or this is the superclass. These are the subclasses. And these subclasses inherit the parent class. Okay. So it would have everything that it has, but it can have its own type that's unique. Mm-hmm. Then we have what's called polymorphism. It's an object's ability to take different forms. So essential ingredients of polymorphic behavior is ability to define a method in a superclass in a superclass and override it in a subclass. So subclass defines a method with the same name. So for example, I have seen a car, SUV, I don't know if it was just a prototype or not, a video recently that shows instead of parallel parking, right, a car, it can be right next to the spot that it wanted to come in and park, but instead of the tires going back and forth, it went sideways. I don't know if you all saw that. And then it will just walk in this way. Car going this way, can you believe that? You all saw that? I don't know if that came out yet. So that would be the ability to override on what it was doing originally in the superclass. Okay, ability to define a method in a superclass and override it in a subclass. So subclass defines a method with the same name. It will still be tires, and then the method in the function, the movement will be different. Instead of back and forth, will be doing sideways. The ability to call the correct version of overridden depending on the type of object that called for it. In a previous inheritance example, showed how to override the init method called the superclass init method and then add it onto that. So the same can be done for any other method. So the method can call the superclass equivalent and add to it or do something completely different. So you're getting what you do with those tires, right? And then the movement was back and forth for the superclass, but then again with the subclass, you can say, you know what, the movement make it going sideways. Okay. So polymorphism provides a great flexibility when designing programs. So you have attribute error exception raised when a method is received an object which is not an instance of the right class. Is instance function determines whether an object is an instance of a class. So these are Boolean basically check-in, and this is the format. So you just get true and false. So this was just a short chapter, just going over the concept of polymorphism and inheritance. Now, what I wanted to mention here was we had this project 7. Some of you sent an email, and you didn't read the instruction here. It says, take the direction of project 5 and convert it to a class and submit. That's all you had to do. Okay, for those of you that missed to read this, because the direction is exactly the same as 5. What did you have to do for 5? Yeah, so everything basically converted into functions, right? All you had to do was functions and loop it back if there is a new customer, right? Here, all you have to say was what? Make it a class, which is the example that we went over last class. And then, of course, you had the hour code that you had to go through. Once you go through this, it gives you a certificate. And then the final exam, which is basically exam 3, is the last exam that you take, which you have next class. All right, that would be it.